So this is the Unreal Editor. This is Unreal Editor 4. It's a very full-featured game engine, but it's really just kind of like an engine. It's very similar to kind of CAD. You have a 3D editor. You can place things. In this editor, you can make terrain maps. And then because I'm a pretty competent scripter with a little bit of programming background, I can do some fun things like make some simulations of how a car might drive on a particular line. Really, I'm just trying to use Unreal here as the editor itself and help me kind of figure out, problem solve the usual stuff you'd want to problem solve for a course design. So, we know we want to design a course. We want to keep space from obstacles. We want to know where the truck's going to be. We might want to actually get a look at what it might look like to people driving the course to figure out where the best place to put cones would be to kind of signal. And I'd like to know, if a car is on a particular driving line, how quickly might that car be traveling in a particular section of the course. What I'm not trying to do here is I'm not trying to figure out an AI to figure out what the best optimal line to drive a set of cones is. That is up to you guys. The event participants will have to kind of figure out from the cones that we put down if the line that the course designer was maybe expecting is actually the quickest way to get through the course. So here is a chunk of terrain map that represents CODA, Lot H. And this was kind of fun to do. This is really just the Google Earth zoomed in. I took a bunch of screenshots. And if you go to Google Earth right now, you might see this if you zoomed in close enough. So I cobbled that together with Photoshop. And one of the challenges I had is I didn't know how to get actual terrain. Like I really wanted to get terrain data in because I wanted to model the slope that Lot H has. Ideally down to the level of the little bumps that we have to deal with. And from some fishing around, I was actually able to buy, I think for $3, a chunk of terrain off a public website, like LiDAR mapped terrain down to the sort of meter resolution. And when I pulled that in, it didn't import into this engine very well, but I just hit it with a big smoothing brush. And you can see that it's actually a decent approximation of what Lot H feels like when you're actually out there. And then what I've got down here is I've got actually a couple of splines that represent the course I tried to lay out for the last spokes event, and then some guesses at where we might set cones to help people through that course. So here you got a crossover, and then you can come around. It may look familiar. Go back through the crossover, back up the hill, and then trying to set up an optional slalom. And so one of the things I can do from this is I can get some decent data. I've got some rough simulations of car physics. Really what I can do is I can simulate the traction circle to a degree. If we know a car can corner at a particular G-force, like if a car can corner at 1.2 Gs, we can actually calculate for a given turning radius how fast that car might be going. And so I've baked that in to this program so that we can hit some buttons, and what I can see at a very slow frame rate is I've got a little color-coded heat map for how fast cars will be traveling in different sections of the course. And so that can kind of give me, as a novice course designer, an idea of, I just laid down a spline. I think the cars are going to travel this route, or I'd like to get them to travel approximately this route. Are they going to get pinched down to a very slow speed at a certain spot, or even what are the highest speeds the car could reach at a certain spot on the track? If I know I want to keep it below, 65 and above 30, my simulations can kind of help me estimate that and hopefully design a more fun course for you guys. And I've actually got two versions of this course overlaid on top of each other so that I could try to set up two driving lines that roughly have the same, basically make that slalom as optional as possible. And one of the limitations of trying to do this simulation-based approach is on paper, sort of in the simulation, these driving lines are very close to equal, and that slalom should have been optional. But everybody who drove it tells me that the one side of that slalom was way faster than the other one. So there's a bunch of reasons for that. One is this isn't a perfect simulation. Another reason is when we actually get out and set the course up on the day of, that course isn't going to go down exactly like it went in the spreadsheet. I actually tried to do a couple things to be able to set up the course pretty close. One of the things I tried to do is I did take this map and I dropped it into Google, because Google lets you drop down waypoints and kind of save off a map. And I did do that, and I put down little cones on Google and saved that off, and I had it on my phone and used my high-resolution GPS transceiver to sort of figure out, but it wasn't accurate enough. And it certainly wasn't fast enough. What actually ended up being way more helpful is just this high-resolution image gives you enough landmarks in Lot H to kind of get a pretty good idea where stuff is. So like all these little boxes and asphalt changes you can find when you're out there actually on the site. And you can get a pretty good idea where that's going to go. And then you're still going to go out and drive the course as a course designer, and you're still probably going to decide on the day of that you need to move some stuff around. That definitely happened. In this corner of the lot, in the simulation, I didn't leave enough space in the corner to feel good about clearance to like the porta potties and everything like that. So we actually moved these cones around on the day of. This got shifted back about to there, and that changed where these driving lines were going to go. These driving lines changed quite a bit. And so people didn't drive a square corner, they drove it a little differently. So I'd actually kind of have to go in and sort of guess at what the right driving line around that new cone placement might actually be. Because what I can do in this application is really just simulate what a car might do if a car's on a given line. What I can't do is I can't figure out the fastest line through the course. But it's pretty cool, and just being able to kind of get out here and put the camera in a specific spot and see what a driver might see as they're looking down that part of the course to kind of differentiate. Do they have enough information? Does it look like a sea of cones? And try some different lines. You know, like I did with this, I can kind of move around different course lines, and I can kind of see how that affects the speed through the course, and get kind of an idea what I might be doing to the actual drivers on the day of. Anybody have any questions?
Yeah, so I'm maybe the obvious one is how did it drive versus how did you think it would drive based on your simulation and in your all of your pre-work, right?
That was great for me. I did really well on PAX that day, especially in the first heat before the stalker was going. It did drive pretty similar. I think I can simulate the traction circle. I can also, I'll actually show you some data for that. I can kind of roughly simulate how cars accelerate. So I've actually got some car data baked in here, and I can open that up. Since I can find it.
I was going to say, if some of the folks have got like AIM Pro or something like that data that they can share with you, would that help build the model?
I'll tell you what I could use. I definitely understanding the sort of G-forces the different cars hit, and not like the absolute peakest peak G that you could possibly see on concrete for a 100th of a second, but just kind of normal peak Gs would be useful. I've really kind of built in kind of data for two cars right now. I've got a Mustang GT, and I have two pieces of data that I really use for that. One is acceleration G-force in each gear. So roughly, how hard is that car going to be able to accelerate in each of its gears? And so the bottom axis down here is going to be speed. So if I'm guessing you're going to be in first gear up to here and second gear up to this point, then you have to shift a third at that. I can kind of roughly pencil in what your forward acceleration is going to be. I've got your lateral G that you might be hitting. I actually pull the packs in so I can compare cars. Because my ideal for something like this is to be able to set up a course that drives that drives equally for different PAX factors, and I can potentially simulate and say, okay, here's a bunch of the cars we usually see at events. I'd like to design a course that's fair for those cars as far as PAX goes. It's a noble dream. The other data I do use a braking map, so how hard can you brake? And right now that's just really, really roughed in, because I do simulate acceleration, deceleration, and then traction circle with a G limit. Looking at my own solo storm data, my traction circle data doesn't look like a circle. It's a weird lopsided oval thing. I imagine that's what you guys get too. And I don't really kind of fully simulate for that yet, but it's actually pretty good. It's good enough to get in the ballpark, and then you're going to get out on the day of, and that course is going to be a unique snowflake a little bit in the end anyway. But for example, here I have the left and the right course set up, and I've got rough data for what the simulation tells me for those cars on that course. I can see how long each of those lines was. Each of those driving lines was about 650 meters. My time estimates for the car data I had was about 35 and a half seconds on the left and the right course. Sorry, the left and the right entry for the slalom. And then I've got what the PAX would be for those for that car. And then I can easily go and take one car and take the car on the left course, and I'm going to change that to a Miata. And according to my data, which doesn't line up with what happened on the day of, that Miata should have 0.6 of a second faster than the Mustang, based on the sort of car data I had for that Mustang. The other interesting thing you can kind of see here running at a low frame rate is I've got a couple of graphs up in this corner which represent cars on course. The blue line is lateral Gs, so we're watching the car transition through the slaloms right now, and then go do something else. And then the white line is momentary speed, so I can see the kind of speeds the cars are running at. And here we're going to get another car that's going to start. And so that brings me to another thing that I can't simulate extremely well yet, and that's how cars transition. If you look at your own solo storm data, you'll see that your car doesn't do the peak on your transitions from left and right aren't as sharp as they are on this graph. But it's a pretty decent simulation. On the day of, a lot of the times we're in the 35s. We actually ended up having 34s, so the real world performance, people were driving faster than my simulation said they could, but not by a huge margin. I've had pretty good luck, and I'll switch over here to RC3 so you can kind of see a course layout for RC3. I did a pretty good job estimating sort of how long the courses were going to take, and that's really helpful as well for kind of figuring out for the crossover, is there enough time to get a car through that crossover before the next car has to go? I've got a pretty good guess at that. If we want to hit a certain interval of sending cars, this kind of simulation can be really effective. I can also kind of get an idea where cars might be relative to each other on course, but as we know, there's fast cars and slow cars, and that's going to throw that off. So this is a course layout I did for RC3. If you guys remember, on the day of, for that event, there was a huge pinch right here. I didn't intentionally want to lay out a pinch, but when I got out actually on site, and I'm down here, I'm in a sea of nothing with very little reference points, and these cones didn't get placed as I kind of wanted to place them. So I think what I'm going to do is I'm going to come back and go back to satellite imagery and get a more accurate texture for RC3 that actually shows the yellow stripes for parking spaces. That's all blurred out on this photo, but I think that'll help me find my bearings when I'm trying to put a cone down. What else we got? What other questions can I answer?
I was going to say, are there systems, GPS systems that are accurate enough to do cone placement? Or
yeah. That's a good question. As far as I can tell, with the Garmin GLO 2 that I've got, it's accurate down to like a meter or 2 meters, but that's not quite enough. Experienced course designers will know that a foot might make a really big difference when you're sort of designing a pinched off area, and that's not quite good enough. I think visual frames of reference actually on the texture of the ground are useful, and in some cases I might be able to set up line of sight references like these two light poles and how they line up and where my cone might line up with those. Those can also be useful, but if you're trying to kind of triangulate that way, it's tough to do that when you're in a hurry in the morning and chucking cones out of the back of the truck as fast as you can.
Yeah. Yep.
I guess in theory I could count how many cones we placed in the simulation and then make sure we don't spend more cones than we have. But this is the course I tried to design for that day. And this is also a good example. I've actually got a 3D cone, but it's backed up by a big cone icon, so it looks a lot bigger in the screenshot than it does on the day of. And this little setup here, which seemed like a great idea to me at the time, as a course, in the simulation, was a terrible idea when we actually tried to lay it out on course, and it was just awful sea of cones. But it's decent. It's a good tool, and I think now that I've got 2 of our 3 main sites in here, it's going to make it easier to rip out courses. It's also, I can pretty easily take solo swarm data from a particular course on the day of and just throw that into a texture and overlay it on here. And just kind of keep courses recorded in here for posterity. So here we've got the red and the green line or some solo storm data laid on top of the site. So I can see, a different course designer, or this is what this car actually did that was recorded and how that looks on the site. And I can kind of get an idea of, keep a record of some other creative ways to use the space that we could, reference in the future. Yeah, so it's a fun tool. Yep.
So my question is a little bit to Rick as well. I'm my inner geek is so attracted by this that it would be so lovely to have like a GPX file of your cones ahead of time, so that I could try to run simulation and figure out the best line. Of course, reality is going to be totally different, but at least it would be fun to try to test different lines and try to figure out on paper what the best line would be. That was just so much fun.
Yeah, it's neat, and that's really what I get to do. And when I'm working on this, that's what I spend the most time with, is tweaking the spline, tweaking the actual line to try to make that line an interesting thing.
Yeah.
And I'm really a novice at course design. There's some really good, detailed course design manuals to read. The guy's thing out of Houston, it was a phenomenal read.
Yep.
Very, very dense with experience. and those guys kind of throw it down on paper, and they're trying to kind of do similar things that I'm trying to do here. They're trying to throw down something that's going to work, something that's not going to be too pinched, something that's not going to be too fast, something that's going to read well. And this sort of approach in 3D does speak to a lot of that, but they have a lot of experience. They have years and years and years of experience doing this, so they know a lot of pitfalls that I'm just beginning to kind of learn. But what I was able to what I spent the most time doing was making small changes to the line to try to achieve, in some cases, a particular result, in this case parity on the slalom, but also just to kind of manage speeds and make sure that there's the right amount of stuff going on. Because again, the line I have to do by hand with the splines here. What I can't really do is actually figure out what the fastest spline is. If you want to know what the fastest way to get through a set of cones is, highly recommend Vivek's course, which is awesome. And he'll talk about spiral and stuff that might blow your mind, or you guys may already know. But it's a really good online course, and it'll tell you how to take a particular set of orange triangular doohickeys and turn that into a fast course time.
So I do think, you mentioned Roger's course design packet and all that, right? I think this is, this complements that, right? This is the next level of, how we can visualize it, and is actually a contribution to the, the overall kind of course design kind of, knowledge base. So I appreciate it. This is great. I also see some value for novices. If I know this is a lot of manual work and stuff, but having a walkthrough video, at least simulated, might be kind of cool, just as a way to give new people an idea of where the course is going to go before they even get to the site. So I can see some training or some novice retention opportunity there too.
Yeah, and that's, all you guys need to do. If I'm designing a course using this tool, I think all you need to do is ask, because because I've got all this, it's trivial to rip out a video or screenshots or a top-down map. If we want top-down maps for spokes events, it's pretty easy to kind of throw it down, and it's going to be a little different the day of. But if people want that stuff published in advance, we certainly potentially could. But yeah, we could easily, if I'm doing the stuff in data, I can easily provide information on what that course might actually look like, or even a fly through.
Yeah.
This editor, this is a really powerful editor. Set the field of view, and it would be really easy to set a camera on the spline, or set the camera at sort of driver height and fly through it. Mm-hmm. You can also kind of get an idea, okay, well, if the truck is over here, what can the truck see? Where does the hill block the view? I can also kind of guess at it, because I've got this much of the course laid out. I can kind of go, all right, well, where might the corner stations go? What's the best place to put a corner station to get somebody run over? Are cars passing simultaneously through a spot? I can kind of get a little bit of that. In this case, this isn't where we put the finish line. We actually moved the finish line from that spot over because there wasn't enough distance here, and that's just me being an inexperienced course designer and not knowing that lot well enough to know that we needed a certain amount of runway to shut the fast cars down.